Hello all, welcome to this session on validation. So far we have covered verification, which is static testing, and now we are going to focus on validation, which is again one of the very important part to understand. So let's begin. What is validation? Validation is a disciplined approach to evaluate whether the final or developed application fulfills its specific intended purpose. Are we doing the right job? So if I go back and try to recall verification, it was, are we doing the job right? Now, are we doing the right job? That means the things have started, prepared, and now I am validating whether those are as per requirements or not. Done by using or executing the developed application. That means execution comes in picture here in validation. It helps in identifying the presence of discrepancies but not their location. If we remember verification correctly, verification helps in identifying the presence of discrepancies and also their location. But here only discrepancies but not their location. It is also known as dynamic testing, as application is actually used testing by running executable. So let's begin. So if you are looking into it, this is the right arm of V model. What is there? So validation is performed through the testing phases on the right arm of V model. We call it as validation. If I see there is one common point between left arm and the right arm, and that common part is called as coding. We have already discussed that code is actually a software work product. So it can be tested by reading. That means you can test a code by using verification methods. At the same time, we can even execute the code and check whether the code is working as expected. That's why validation starts at coding level only. Going ahead, we have unit testing, integration testing, system testing, and acceptance testing. These concepts are new for you. These are called as levels of testing. Please pay attention. This is a very important concept because this gives an exact idea how actually testing happens when the application is getting developed. What is the concept of unit testing? What is integration? What comes under system? And who does acceptance and what is there? All these questions will get answered here in these sessions. Now, in the current session, we are going to cover two levels, unit and integration. And in the next session, we will be covering system and acceptance. So as a whole, this particular V model, to complete this particular V model, we need these two sessions. So let's begin. First of all, let's understand the difference between verification and validation. So there are categories under which we have defined the differences. First is definition. Verification says that it is the process of evaluating documents, work product, not the actual final product of the development phase. Whereas validation definition says the process of evaluating software application during or at the end of the development process. Okay. Role ensures that work products meet their specified requirements, and here demonstrates that the product fulfills its intended use when placed in its intended environment. So this is validation. Slogan, are we building the product right and are we building the right product? Evaluation items, plans, requirement specs, design specs, code, test cases, etc. And here the actual product or the software application. Activities, reviews and walkthroughs, which we have already gone through. And then in validation, activities are levels of testing. So all the activities are divided into different levels. So adequate verification will lead to less issues getting discovered in a validation process, as most of the issues are already discovered and corrected. Reduce rework and repair at the validation stage. So this is a benefit. Now, Adequate validation will ensure that the developed software application is as per software artifacts freezed in verification. So that's why the it is said that verification and validation actually complement each other. So let's focus on these levels of testing. Now, I want to make it simplified. So just explaining you levels. What do you mean by levels? Levels are kind of phases through which the, the application travels. Like for example, if I want to make a big application like e-commerce site or online shopping website that is getting developed, but is it going to get developed overnight in a single shot? Answer is no. It may get developed in pieces, and every individual piece again needs to get tested. Again, when two or more pieces are getting developed, those needs to be tested that how collectively they are working. End to end needs to be done, and a person or the customer who asked us to develop that software will definitely test. This is a nutshell in these levels of testing. Let's explore one by one in detail. So, the first level, unit testing. Defi- Definition of unit testing says that the smallest piece of code tested in isolation to verify its behavior. So the smallest piece of code, that means a small functionality or a partial functionality which is required. So anything which is a single unit can be considered as a single unit is tested under this unit testing. Who does it? It is usually done by developers. Obviously, the piece of code or the smallest piece or a bigger piece is with developers, so they will check whether that particular piece of code is working as expected. How to do unit testing? Manually or use of tools like JUnit. So JUnit is a tool which supports this unit testing. Just repeating, unit which is a smallest piece of code, and unit testing means the smallest piece of code tested in isolation to verify its behavior, generally or usually done by developers, and can be done manually or with the use of tools like JUnit. What is its purpose? Ensures that the code meets the requirements. Okay, now this is being theoretical. Let's take a simple example. If a team is working on a product, let's take a simple example, maybe calculator. So the entire calculation is getting developed, but it will not get developed as a whole. It will get developed in pieces, or we can say functionality wise. Now, customer says that the calculator should do addition, subtraction, multiplication and division. Fair enough. Now, this entire application is divided into four pieces. One, focus on addition, second on subtraction, third on multiplication, fourth on division. My developers have started working. In the current release, which is going out to the customers, developers focus is on this addition functionality. So addition is the smallest unit. So this unit will get tested in isolation. Developers have written the code. Obviously, the developer will compile the code and check at least once with at least single input whether that code is working correctly or not. For example, enter 2 plus enter 3 and it should give a 5. So this is the smallest example, or the what you can say quick example which I gave here. This is being tested under this unit testing. But tested means developer has gone through the code and validated. Now, what are the benefits? These are the benefits as I told you in a simplified manner. Faster debugging, easy to isolate errors. Of course, when I have smallest piece of code, I'm looking into it. Code size is small. I don't have to, look into the entire code repository. I can figure what are the issues and where the issues are exactly. Faster development. Enhancements can be performed with confidence because now developers knows that in which area or in which function or in which lines of code they need to make changes. Reduce future cost. Simplifies next level of testing, that is integration. So that's all from this particular unit testing part. I will just repeat here. Unit testing is a smallest piece of code tested in isolation. Isolation means isolated from other functionalities or other lines of codes. Who does it? Generally, it is done by developers. What are the benefits? Faster debugging, and then you can proceed with confidence. That covers unit testing part. Now, let's move to the next level, which is integration testing. And this is a very interesting and bit difficult to understand level. So, let's begin. Integration. So, whenever this integration word hits to our mind, we think that when I say integration, integration can be between two functionalities. Now I will go in more technical words, maybe between two modules, maybe my application is interfacing with another application, or maybe my application is interfacing with altogether a new application outside of it. For example, my online shopping application interfacing with bank gateway is again integration. So guys, what is the thing which is getting established over here? We call it as interfaces. And normally when this interfaces gets developed, what gets transferred between one module to another or from one application to another? One, data, second, control. I'll give you a simple example. When you actually do online shopping and when you are checkout, you click on pay, you will get directed to bank gateway. Here your data is getting passed. That means you can enter your ID password and you can get it logged in. And when you are there and when you are making a payment, you cannot just come back in the shopping cart and see what is there or make changes. No, it is not possible. That means the control has gone ahead. So when we talk from interfaces point of view, these interfaces are mainly data flow and control flow. Let's understand. Purpose: to confirm that the individually tested units can work together. Integration is dependency between modules through one module calling other module, transfer of data from one module to another, and logical dependency between two modules. One module can be executed only after other completes. Like for example, if I am testing integration for email application, then when I click on send email, then and then only my email can be seen in the sent item. So there is a dependency. Unless the functionality of a send email works correctly, it will not appear in my sent email box. So this is how it works. So all modules may not be get ready at the same time to form the subsystem or system. Now this is a totally different concept. uh, there is a high chance that in the entire development phase, when the application is getting developed, there are certain modules which are not completely ready due to any number of reasons, or maybe for that particular module the complete functionality is not required, so partial development is done and it is integrated. But how it will work then? I mean, if the module is not ready and if I'm trying to gel it with the completed module, the entire ecosystem is not ready, then in that case what can be done? And this is a question. So to answer this particular point, we have something. Let's have a look. Integration testing starts at a module level when various modules are integrated with each other to form a system or a subsystem. More stress is given on interfaces between the modules. Now, if I want to go for integration, there are certain defined approaches. Okay, and those are bottom up, top down, critical part first, and big bang. Integration testing is also done between applications under test and other external systems interfacing with it. That's what I said. Online shopping application interfaces with payment gateway. Interesting part here to learn is about these particular approaches, like bottom up, top down, critical part, big bang. What it is exactly? Let's understand. Bottom up approach. In bottom up approach, testing starts from the lowest level of modules and progresses towards higher level modules. Question: what if any module is not completely developed? I think a couple of slides back we were discussing the same thing, like the module is not ready or the partial ready, then and it should have some interface from between two modules, or the control or data is passing through that particular module. How can I test? Answer is here. Okay, there is something called as drivers, which is a dummy module. Now, drivers, those are created because the module is not ready, which is required to have this particular integration. What is driver? Drivers are used to simulate the higher level modules that invoke the lower level modules. That means, let's go back again to the same example. Now, send email is not active or is not completely ready. I will create a dummy module which will just send an email, and I have to check the functionality of the sent item folder whether it is there or not. So this is where the driver comes in a picture, or the dummy module comes in a picture. These drivers provide the necessary input data and control the execution of lower modules needed. So this is driver concept. Again I am repeating, if we are going for a bottom up approach, drivers are introduced. But there are still some questions which are unanswered. Like what are the benefits for bottom up approach, and in which scenario, in which cases I should go for bottom up approach. Let's look into this. First, let's understand this example. Suppose you are testing a software application with three modules, A, B and C, where A calls B and B calls C. Now, you will start testing with module C. A driver is created for module C to test it independently. Once C is tested, you can move on to the module B. Here, a driver from module B is created which interacts with the already tested module C. Finally, module A is tested after ensuring both B and C are functioning correctly. So, this is how this particular insertion of drivers is done, and even if the modules are not 100% ready, we can still go for integration. Now, something in top-down approach. In the top-down approach, testing starts from the highest level modules and progresses towards lower modules. Here also we may need dummy modules, but here the name is not drivers, but here the dummy modules are called as stubs. Stubs are used to simulate the lower level modules that are invoked by higher level modules. These stubs provide predefined response to the calls made by the higher level modules. Example, suppose you have the same modules A, B and C. You start testing with module A. Stubs for module B and C are created to test module A independently. Once A is tested, you can move to the module B. Here, the stub for module C is created, allowing B to be tested with already tested module A. Finally, module C is tested independently after both A and A are confirmed to be working correctly. So it is exactly the reverse. Okay, so now this is the approach, top down, and the usage of stubs is implemented. Summary: bottom up approach uses drivers to simulate higher level module. Stubs are rarely used. Top down approach uses stubs to simulate lower level modules. Drivers are rarely used. Both approaches have their own advantages and can be chosen based on the specific needs and the structure of the project. Question: when to use bottom up integration testing? When you have a stable lower level modules. Use this approach when lower level modules such as utility functions or libraries are already stable and well tested. Testing starts from these modules to ensure their functionality before moving to the higher level modules. This is one criteria. Second, test driven development. If you are following the test driven development approach, bottom up is advantageous because it allows you to build and test small units first, gradually integrating them into larger systems. Criteria number 3, no immediate need of higher level modules. I mean, there is a chance that these type of higher level modules are not required, and when the higher level modules are either not developed or not crucial at the early stages of integration testing, you can start with lower level modules to ensure a solid foundation. Now, like the bottom up, answer when to use top down integration. First criteria, critical high level modules. Use this approach when high level modules such as user interface or core system functionalities are critical. We need to be tested first to ensure they meet the requirements. Second, early prototyping. When you need early prototypes or demonstrations to stakeholders, top down is beneficial as It allows you to test and showcase higher level functionalities early in the development process. Third, clear system architecture. When you have absolutely clear architecture, no ambiguity or no unclear requirement, then you should go for this particular top-down approach. Okay, choosing the right approach. Now we have discussed so many things like top-down, bottom-up, but the choice between bottom-up and top-down integration testing often depends on the structure and the complexity of the system, the stability and the readiness of different modules, project timelines and development methodologies, the criticality of certain components or functionalities. So, before deciding any of the approach for integration testing, at least these many criteria are always considered, and based on their answers, the approach can be decided. In some cases, a hybrid approach that combines element of bottom-up and top-down integration testing can be used to leverage the strength of both the methods. So that covers this top-down, bottom-up approaches. The third approach is integration testing is critical part first approach. This is very much widely accepted and used, where design, implement and test critical part of the system first. Important for time critical systems where the performance of the critical part makes up for the performance of the whole system. Just keep this particular point aside. The second point, just think critical part first. In our life also, we only do those things which are really critical for us at this particular point of time. Rest all we put it on a priority too. This is critical part first. Here people identifies which part needs to be taken first, because that is very much crucial and critical from my customer point of view. When to use critical part first integration approach will give answer to what I am saying. High risk components. Risk. We have discussed risk, a potential threat. Now, when there is a high risk component involved, we should test that thing first. When a certain components are identified as high risk due to their complexity, importance, or potential to affect other parts of the system, testing them first helps mitigate these risks early on. Core functionalities. If specific functionalities are central to the system's operations and their failure would render the entire system unstable, it's crucial to test these parts first to ensure overall system stability. Dependencies. When many other components depend on critical part, testing it first ensures that these dependent components can be integrated and tested smoothly later on. So remember, these are few criterias, okay, which actually decides or which helps to decide why to go for critical part first. Some more, early validation. If stakeholders need early validation of the system's core functionality or core features, focusing on critical part first allows you to demonstrate key functionalities sooner in the development process. Just before few slides we see that if my customer want something to be checked or to understand, we should go for top down. This is again one of the approach which helps in early detection. 5. Resource allocation. By addressing the most critical part first, resources can be allocated more effectively to fix issues that arise in these areas, ensuring a more robust and a reliable system. So, advantages: early detection of major issues, identifying and resolving critical issues early can prevent cascading problems and delays later in the development cycle. Focus testing concentrates efforts on the most important parts, ensuring they are thoroughly tested and reliable. Stakeholder confidence. It's a very simple thing, guys, that my stakeholders are happy or my stakeholders are confident with me. But when they will realize that whatever important part of my application is, that particular part is taken care well before in hand, so as to avoid further delays or further issues, the customers or the stakeholders will have a confidence in this particular entire development process. I'll give you some example scenario here. Imagine you are developing a medical device with both hardware and software components. The software that controls the device's core functions, such as monitoring and altering vital signs, is critical. Testing and integrating this part first ensures that the device performs its primary function correctly, before integrating less critical feature like the user interface or data logging. So this is a very clear and self-explanatory example which is mentioned. So you can revisit. Now by focusing on the critical parts first, one can ensure that the most important and the potentially problematic components are working correctly, providing a solid foundation for the rest of the systems. This covers our third approach, which is critical part first. Now, the last in this, Big Bang integration. A common approach in the non-process oriented organizations, all the modules are integrated at once. So everything is integrated once and tested. So just imagine what can be the problems. Many advantages and few advantages, hard to debug, hard to check interfaces. Definitely, because we will never come to know that because of which module the interface is getting in trouble. Location of the defect is difficult to find. Can start late as all the modules need to be ready. No stubs and drivers are required. But I don't think this is an advantage because the weight more is to disadvantages of this. Okay, so this covers our two first two levels, which are unit testing and integration testing. Now the question is, unit testing, I said, usually done by developers, and here in this diagram you can see integration testing, developer and tester. Tester understood, but why developer? The answer is, when we select any of the approaches and if the modules are not ready, then you need a developer to develop stub or a driver. You get it from the developers, your stub or driver, use it, test it, and go ahead. And that's why integration testing is an activity for both the sides, development and testing too. Okay, guys. So I'm sure, or I think that this particular session gave you some insight on how levels are there and why two levels are the first two levels, what are their roles and what are the purpose and etc. So thank you very much for listening. For next levels, I'll catch you in the next session. Thank you.